All right, students. So today I'm gonna show the second version of the test. So this is if you had Mr. Felix, Miss Mahika, Miss Colby, Miss Audrey, and Miss Elena. This is going to be the test that you're looking at. So this first question here is telling us to read the biographies for each statement, create a diagram to show the connections between patients and their symptoms. So we're looking at these patients here, their symptoms, and what their connections are, connections with other patients. So here I'm going to put my little diagram. So first of all, if you're wondering how to make this diagram, if you go back to page 1.11a, when we did the unit review, we did this, sorry, 1.11a. We did this in the first page, creating a diagram to show those connections. So if you want to look back at this to help you, you can also use that. But this is what we have here. So the first thing that I'm going to do is I'm going to write the names of all of the patients. So we have Mr. Felix, we have Miss Mahika, we have Miss Colby, we have Miss Audrey, and then we have Miss Elena. Great. So let's find the connections between them. So first, let's look at the symptoms. So let's see. Mr. Felix has a sore throat, but it doesn't look like anyone else has that. But let's see. Let's keep going. A headache. So who has a headache? Mr. Felix has a headache. Miss Mahika has a headache. Miss Colby has a headache, and Miss Elena has a headache. So we're going to draw a connection between all four of them. So let's see. So we have Mr. Felix. We have Miss Mahika. We have Miss Audrey, and we have Miss Elena. And they all have a connection, which is that they all have a headache. So I'm going to write here headache. Okay. All right. What else do we have? Let's see. So let's see. Miss Mahika has symptoms of vomiting. So does Miss Audrey. So let's put them together. Miss Mahika and Miss Audrey. Oh, looks like I forgot to wait. Oops, I made a mistake. So headache is who does not have a? Oh, Miss Audrey does not have a headache. Sorry. Let me correct this. Miss Audrey does not have a headache. It's Miss Colby. Okay. Okay. Let's see. Then what else? Fever. So Miss Colby and Miss Audrey both have a fever. So I'm going to put a curve, a line between them, and put, say, fever. Fever. Okay, there we go. And then this, yeah, sorry, this one here is vomit. They both have. Okay, let's see what else. So connections to other patients. So Mr. Felix plays soccer with Miss Audrey. So I'm going to draw a connection between them and put soccer because they play soccer together. Okay. Then we have that Miss Mahika works with Miss Audrey. So they work together. So Miss Mahika and Miss Audrey, they work together. Miss Colby is friends with Miss Elena, so let's put those lines together. Miss Colby to Miss Elena. They are friends. So here I'm going to put friends. Oops, friends. All right. Then what else? We have that Miss Audrey is roommates with Miss Colby. So let's put these two together. So Miss Audrey and Miss Colby, they are roommates and they live together. It means the same thing. Roommates. Okay. Let's see. And then we have that Miss Elena is also friends with Mr. Felix. So they are friends. All right. So your diagram might look something like this. We have all the patients and all the connections between them. Sure. All right. So our diagram is going to look something like this when we're finished. Something like that. All right. Great. And so that's how you do this one. Let's go on to the next questions. So here we go. So now we're looking at BLAST. So BLAST we did, so you can look back here because we talked about BLAST on 1.4 within 1.11a. Also, you can just go to 1.4 in your notebook and you have that information there as well. So it says here, what is the most common pathogen among our patients? So let's see. In this case, so let's look at the pathogens that each patient has. So here we have Mr. Felix has Streptococcus pyogenes, Miss Colby has Streptococcus pyogenes, and Miss Audrey has Streptococcus pyogenes. So the most common pathogen among our patients is Streptococcus pyogenes. Okay, great. It's the one that happens 3 times. Let's see, what is the purpose of using BLAST? So you can, again, this question was taken directly from 1.11 A. This question here, what is the purpose of BLAST? You can also find it here. The purpose of BLAST is to find the identity of the pathogen. So we take a DNA sample from somebody, we analyze the sample, and then we find its identity using BLAST. So the purpose of BLAST, using BLAST, is to identify the pathogen affecting the patient. Right? So we take a DNA sample of the pathogen that somebody has, we then analyze it and we find what it is. Great. Okay. Now in this part, it's asking us it says answer the questions by writing in complete sentences. Write as much as you can in English. Use your science connection words. So we have our science connection words. Science connection words. And I gave these to y'all each in your own languages. So you can also, again, you are always welcome to use those. So let's see, if we're looking at the connection words, so these are when we're looking at similarities and differences. So similarities and differences, when we want to talk about things that are similar, let's see. So here we have it in Chinese. Yeah, connection words. Here we have it in Spanish. Here we have it in Arabic. So let's look at, so if we want to talk about similarities, so first we want to talk about similarities. So what are the 2 things that people have in common? Similarities. Let's see. So similarities, we're going to use the word similarly, likewise, to, also, or both. So both is usually the easiest one to use. So let's go with both. So what's something that 2 patients have that's the same? So let's see. Mr. Felix has Streptococcus pyogenes, which is a bacteria. And Miss Colby also has Streptococcus pyogenes, which is a bacteria. So I can write both Mr. Felix and Miss Colby have the Streptococcus pyogenes pathogen. Both of them have it, right? Okay. What's another similarity? So we can say that both Mr. Felix and Miss Audrey can treat their pathogens with antibiotics. So I can say, let's use a different one. Like, let's use the word to. So Mr. Felix can treat his pathogen with antibiotics. Miss Audrey can treat her pathogen with antibiotics too. So you don't have to write this one again. You can use different connection words, but as you see, right, we use the word both in this case. And here we use the word to, right? Those are 2 of our connection words, both and to. Great. Then let's look at some differences. So what are two differences that we have here? Well, Miss Mexica has influenza B virus, but Miss Audrey has Streptococcus pyogenes. So those are different. So let's try the one that the word but. So we're going to use the word but. Miss Mexica has the influenza B virus pathogen, but Miss Audrey has the Streptococcus pyogenes pathogen. We use the word but because there's a difference. There's a difference between those two. Okay, let's find another difference. So we can say that Mr. or Miss Elena can treat her pathogen with antivirals, but Miss Colby can treat, or right, Miss Colby, however, she can only treat her pathogen with antibiotics. So here we have antivirals and antibiotics. So let's find another difference word. So let's use the word while. So you can put while at the beginning or in the middle of a sentence. It's the same thing. So I can write while Miss Colby can treat her pathogen with antibiotics, Miss Elena can treat her pathogen with antivirals. So we use the word while. You can also put the word while here. So Miss Colby can treat her pathogen with antibiotics while Miss Elena can treat. So it's the same thing, but we use the word while here. Great. All right, let's go on to the next one. So it says here, Miss Elena has blood type A. What type of self-antigen does Miss Elena have? So again, you can go back to 1.11a, come down here. So we see where we see the blood types. You can also go to 1. So this is also found on page 1.6 instead of your notebook. If I go to 1.6, antibody and antigen, we learned here that if I have blood type A, right, I have antigen A. If I have blood type B, I have antigen B. If I have blood type AB, I have both antigen A and antigen B. And if I have blood type O, I don't have any antigens. I don't have any self-antigens. So here it's saying that Miss Elena has blood type A. What type of self-antigen does Miss Elena have? So if she has blood type A, she has antigen A. That is her antigen. So I'm going to write here that Miss Elena, and right, I need to answer in a complete sentence. Miss Elena has self-antigen A. Okay, then the next question is Miss Mexica has blood type O. What type of antibodies does Miss Mexica produce? So if we go back here, blood type O, what kinds of antibodies will it be formed? Well, if you have blood type O, you're going to form both antibody A and antibody B. So we have two. So I'm going to write Miss Mexica produces antibody A and antibody B. Okay. Then it tells us Mr. Felix has blood type B. What type of blood can Mr. Felix receive? So let's come back here. So blood type B, if I have blood type B, I can receive blood type B and blood type O. So here I'm going to write that Mr. Felix can receive blood type B and blood type O. Great. All right. Now let's go down here to number 8. So we're looking at concentration. So for concentration, again, now you're going to move on to 1.11b of your unit review. So concentration you can also find this information on 1.7 instead of your notebook on concentration. With concentration, so the way that we calculate concentration is by looking at the solute and the solvent. So the solute is the thing that dissolves. The solvent is the liquid that it dissolves inside of. So for example, salt water is a solution. The salt is the solute. The solvent is water, right? The salt is the thing that is dissolving. So it says, Miss Elena makes soup every morning by adding salt and water to cup 1. What is the solute and what is the solvent? So the thing that's going to dissolve is salt. The thing in which it's dissolving the liquid is water. All right. To make the perfect soup, Miss Elena adds 20 grams of salt and 400 milliliters of water. What is the mass, volume, and concentration of her soup? Remember to add the units. So the mass is the amount of salt, the amount of solute. So there's 20 grams. So I'm going to write here 20 grams. The volume is the water. So how much water do we have? We have 400 milliliters. So I'm going to write 400 milliliters. And then it's asking to calculate the concentration. So I can go to my concentration triangle. What I do here, the way to use this triangle, I'm going to cover the letter that I'm trying to calculate concentration, which is the letter C. So I'm going to cover the C. And what I'm left with is that concentration is mass divided by volume. So the mass here is 20 grams. So I'm going to write 20 grams in the top. And in the bottom, I want to put the volume, which is 400 milliliters. So if I calculate 20 divided by 400, I go here to my 20 divided by 400. And I get that this is 0.05. So right here, I'm going to write 0.05. 0.05, and the units are grams per milliliter. Cool. All right. Then for number 10, it says, Miss Elena takes 100 milliliters of soup from cup 1 and puts it in cup 2. What is the mass, volume, and concentration of each cup? So if I'm taking 100 milliliters from this cup and putting it over here, right? So initially I had 400 milliliters. So when I take out 100 and then put it in the second cup, now I only have 300 milliliters left. And the other cup, this cup cup 2, is going to have 100 milliliters. Right? Because there was a total of 400 in cup 1. Then I put 100 instead of cup 2. So cup 1 now has 300 milliliters, and cup 2 is going to have 100. So what about the concentration? So if you look back here, right, when we were talking about concentration, right, if you change just the container of a solution, you do not actually change the concentration, right? It's the same liquid still. It's still the same liquid. It's going to taste exactly the same. We haven't changed anything about it fundamentally. So here we're going to write that the concentration is the same. This concentration here has not changed. It's the same soup. We have not changed that. So the concentration is still 0.05 grams per milliliter in both cases. To find the mass then, how much salt is in each cup? Well, we can use this equation. We can go back to our concentration triangle again. So we're trying to calculate the mass now. So you cover the letter M, and you have volume times concentration. You multiply these two. So in this case, our volume is 300 milliliters, and our concentration is 0.05. So I'm going to calculate that. So we have 300 milliliters times 0.05, and that leaves us with 15. So that means that we have 15 grams of salt in cup 1. In the second one, well, let's do this again. So volume is 100 milliliters, concentration is 0.05. So 100 times 0.05 gives us 5. So here we have 5 grams. Great. And that's how we do this part. All right. Now for Eliza. So Selling is here, Eliza. So answer the following questions by writing complete sentences. Write as much as you can in English. The first one here says, what antigen will the primary antibody bind to? So in this case, we're going to go to 1.11c, which is the other unit review. This is the last part, where we put these in order. So what it says here is that the primary antibody binds to the antigen. So when we add this sample here, so this is the antigen. And in here, then we have the antibody that's going to bind to the antigen that we're looking at, the antigen of interest. In the case of the experiment that we did, we were looking at Neisseria meningitidis. In this case, our pathogen is Streptococcus pyogenes. So the antigen, or the primary antibody will bind to the antigen for Streptococcus pyogenes. So for the Streptococcus pyogenes pathogen. Great. What about this part? Why do we add a wash buffer? So if we look back here, a wash buffer, what it does is it removes the excess of the antibodies it removes the excess primary antibody and it removes the excess secondary antibody. So we use it to remove excess antibodies. We add a wash buffer to remove excess primary and secondary antibodies. How do we know who has the highest concentration of the pathogen? Well, so if we look back at 1.9E, when we were talking about our ELISA, right, the brighter a sample is, the more of the concentration that the patient has. So we will know who, who has the highest concentration of the pathogen by looking at the brightness of the samples. Okay. Which patients are positive for Streptococcus pyogenes? So if we remember back here, right, our samples for Sue, Jill, Wanda, and Maria were all positive. So if we go back to our ELISA results, our ELISA lab results, right? In the ELISA lab results, we had 4 people. So Sue, Jill, Wanda, and Maria all had samples with color. So all of them have the disease. So in this case, we have Mr. Felix, Miss Colby, and Miss Audrey that have color in their sample. So that means all 3 of them have the disease. So we have Mr. Felix, Miss Colby, and Miss Audrey. Those 3 have the disease, have the pathogen. What is the brightness in each sample? Well, the brightness is going to be this sample, this one right here. So Mr. Felix has a brightness of 41.2, Miss Colby has a brightness of 13.4, and Miss Audrey has a brightness of 15. So here I'm going to put 41.2. Miss Colby has a brightness of 13.4, and Miss Audrey has a brightness of 15.1. Okay, so which sample had the highest concentration of the antigen? Well, we know that that's dependent on the brightness, how bright they are, right? So the patient who had the highest brightness in this case was Mr. Felix. He had the brightest sample, right? His sample has the most color. So that means that he has the highest concentration of the antigen. Mr. Felix's sample had the highest concentration of the antigen for the Streptococcus pyogenes pathogen. I know this because his sample is the brightest. Okay. Who do you think patient 0 was? Well, if we go again, going back to our 1.9E, we go back to 1.9E, patient 0 is the first person, right? The first person was the first person to be sick. If you remember from our graph here, right, the first person who got sick is the person who has been sick for the longest. So whoever's been sick for the longest, they have the highest concentration of the pathogen. So what I'm going to write here is, well, the person who has the highest concentration is Mr. Felix, right? We know this from before. So that means he's patient 0. Mr. Felix, or I think Mr. Felix is patient 0 because his concentration of the pathogen is the highest. Patient 0 is the first person who got sick. So if so that person has the highest concentration. But that's how you do this one. Great. I'll talk to you all in a bit.